Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. So having considered electronic configuration, electron, energy level, and want to look at topical questions on electrons, energy level, and atomic orbitals. So we'll be starting with paper 1. These are typical examination questions and they are A-level questions. So I want you to pay attention and so that you know how to answer the questions. Now, the question before us is, what is the order of increasing energy of the listed orbitals in the atom of what? Titanium or titanium. So it's as simple as ABC. All we just need to do is to follow the above principle, which is the building principle, whereby electrons, are filled starting from what? The innermost shell to the what? Outermost shell. The shell with the lowest energy level to the highest energy level. So titanium is a transition element. So the order of increasing now, if you look at A, 3s, we have 3s, 3p, 4d, and 4s. So it doesn't follow the above principle, the building principle. So it doesn't follow the order. So A is not the answer, A is wrong. Then if you look at the next one, B is 3s, 3p, 4s, and 3d. So B is the correct answer. B is the right answer. If you look at C, C doesn't follow the order. D doesn't follow the order. D is wrong and C is wrong. So the right answer is what? B. Going by the what? Abba principle. So the next question goes, use of the data booklet is relevant to this question. Atoms of element X have 6 unpaired electrons. What could be element what? X? A is carbon, B is chromium, C is iron, and D is selenium. So we are to use the data booklet to check the atomic number of the elements from the periodic table. Then we'll write the electronic configuration to know the element that have 6 unpaired electrons. So if we are to start with carbon have atomic number. The atomic number of carbon is 6, which is 1s2, 2s2, then 2p2. So the p subshell have 3 orbitals, which are 1, 2, and 3. So if we have 2p2, so you have only 1 and 1. So it doesn't have 6 unpaired electrons. So carbon is not the answer. So we'll go to the next option, which is chromium. Chromium is 24. If you look at the periodic table, chromium is 25. The atomic number of chromium is 24. So you have 1s2, 2s2, 2p6, then 3s2, then 3p6, then 4s1, then 3d5. So for 4s1, so we'll have for 4s1, I think this one will have the s subshell have 1 orbital, so we'll have 1 unpaired electron here. Then when it comes to 3d5, the maximum number of electrons that the d subshell will take is 10. So we'll have 5 electrons here. So for the d subshell, there are 5 orbitals. So if we are to arrange 5 electrons, so we are going to get 5 unpaired electrons, 3, 4, and 5. So we'll have 5 electrons, 1, 2, 3, 4, 5. So we'll have 5 unpaired electrons and 6. So this is 1. This is 1, this is 2, 3, 4, 5, and 6. So the element X that have 6 unpaired electrons is what? Chromium. So the answer is what? B. B is the correct answer to this question. So since it is multiple choice, we need to check C and D because B is the what? B is the answer. But if B is not the option, we'll go back to C or we'll check D to know if it is what? It is the answer. If it is the answer, so it's as simple as what? A, B, C. So just follow the rules. So the next question is, which atom has its outermost electron in an orbital of the shape shown with principal quantum number 3? So if you look at the shape before us, I think this is the shape of what? A p subshell, a p orbital, which is what? Dumbbell. So what we have to do here is to look at the elements and get the atomic number, write the electronic configuration. So we're going to see, then we check the element that have what? The P subshell in principal quantum number 3, that is in the third shell. So let's start with sodium. Sodium is 11. Sodium is 11, which is 1s2, 2s2, 2p6, then 3s1. So on the principal quantum number 3, sodium have the s subshell, which is spherical in shape. The s orbital is spherical in shape. So sodium is not the answer. Sodium is not the answer. Let's go to the second, which is chlorine. Chlorine is 17, which is 1s2, 2s2, 2p6, 3s2, then what? 3p5. 3p5. So they say which atom has its outermost electron in an orbital of the shape shown with principal quantum number 3. So this is a dumbbell shape, which is a p subshell, p orbital. So which is p. Then principal quantum number 3, which is the third shell. So the answer to this question is what? B, which is what? Chlorine. Chlorine has what? The p orbital in its outermost electron with principal quantum number 3. So the correct answer is what? B. So it's as simple as what? A, B, C. If you look at C, if we are to write the electronic configuration of C, the principal quantum number is in the fourth subshell, and it's an s orbital. So C is not the answer. Then if you go to D, it's not in the electron is not in principal quantum number 3, and even though it's a p subshell, or it's a p orbital, but it is not principal quantum number 3. So the correct answer to this question is B. B is the answer, which is what? Chlorine. Now the next question says an atom has 8 electrons. Which diagram shows the electronic configuration of this atom in its lowest what? In its lowest energy state. So it has what? 8 electrons. 8 electrons. So I think it will be 1s2, 2s2, then 2p4. Now if I are to follow the Hund's rule, that in filling electrons in orbitals, you fill singly before you start pairing. So if you look at 1, it disobeys the Hund's rule. So A is wrong. A is not the answer, because on the P you have what? You have 4 electrons on the P subshell. So you have to fill it singly before you start pairing. So A is not the answer. Then if you look at B, so you have 1s2, 2s2, then 2p4. So you fill singly before you start what? You start pairing. So the answer to this question is B. So B is the correct word answer. It obeys the Hund's rule. It obeys the Pauli exclusion principle, and it obeys the Albert word principle. If you look at C, C is not the answer because it disobeys what? It disobeys the Hund's rule. You fill singly before you start what? Pairing, and you start from the lowest energy level to the highest what? Energy level. Then D is also wrong. That is it. You start from the lowest energy level to the highest energy level. So the correct answer is what? B. So the next question is, use of the data booklet is relevant to this question. The electronic structures of calcium, krypton, phosphorus, and an element X are shown. Which electronic structure is that of element what? X? So we're instructed to use the data booklet. So the data booklet is to check for the atomic numbers of the element from the periodic table. So the first element is calcium. Calcium have an atomic number of 20. The next one is krypton. If we are to use the periodic table, krypton is what? 36. Then the next one is phosphorus. Phosphorus is 15. So we are looking for element what? X, of which we don't know. So we look at the options step by step, one by one. The first one, if you look, we have 2 plus 2 plus 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 2, 13. So A is 15, which is what? Phosphorus. So A is not the answer. If you look at B, B is 20, which is calcium. So B is not the answer. If you look at C, C is 10, 12, 12 plus 6, 18, 18 plus 2, 20. So this one is what? 26. Then if you look at D, D is 10, 20. This is 10, 12, 18, 28, 30. So D is what? 36, which is what? Krypton. So the answer is what? C. The correct answer is C. So D is not the answer. So the correct answer to this question is what? C. So it's as simple as what? A, B, C. So the next question is a simple ion X contains 8 protons. What is the electronic configuration? So with a positive charge, that means there's loss of what? 1 electron. So the number of electrons will be what? 8 minus 1. That's the number of protons minus the charge. So the number of electrons will be equal to what? 7. So the electronic configuration will be what? 1s2, 2s2, then what? 2p what? 3. So the correct answer to this question is what? Is B. So as you can see, it's as simple as what? A, B, C. So the next question is, which element has an equal number of electron pairs and of unpaired electrons within orbitals of the principal quantum number 2? So we say principal quantum number 2, that is the second shell. So what we'll have to do is to write the electronic configuration. They say which element has an equal number of electron pairs and of unpaired electron within orbitals of principal quantum number 2. So this is beryllium, which is the first one. This is beryllium, atomic number 4. It is 1s2, 2s2. So within the principal quantum number 2, we have what? 2 electrons on the s subshell. So if you arrange the electrons in an orbital, it has what? 2 electrons on the s subshell, 2 paired electrons, and there is no unpaired electron. So the answer is not A. A is the wrong answer. Now let's go to B. The atomic number is 6, which is carbon, which is 1s2, 2s2, then 2p2. So on this principal quantum number 2, the s subshell, 2 electrons which are paired. Then on the p subshell, within the principal quantum number 2, we have 2 electrons that are what? Unpaired. So the answer to this question is B. So the answer is B. As you can see, if you look at C, C is not the answer because within the principal quantum number 2, which is 2s2 and 2p3, we have 2 paired electron and 3 unpaired electron within the principal quantum number 2. So C is not the answer. If you look at oxygen, which is D, D is not the answer. Within the principal quantum number 2, we have 2s2 and 2p4. So within the principal quantum number 2, we have 2 paired electrons on the s subshell, and we'll have what? 1 paired and 2 unpaired on the p subshell. So the answer is not D. So the correct answer is what? B. So as you can see, it's as simple as what? A, B, C. Now let's go to the next question. They say, in which pair do both atoms have 1 electron only in an s orbital in their ground state? In which pair do atoms have only 1 electron? Have 1 electron only in an s orbital in their ground state? If you look at calcium, they look at calcium. Calcium is 4s2, so it doesn't have 1 electron in its ground state. So the answer, look, if you look at scandium, scandium is 4s2, then 3d1. So the answer is not scandium. Now let's go to copper. If you look at copper, copper is 4s1, then 3d10. So then beryllium is what? Beryllium is 4, which is 1s2, then 2s2. So B is not the answer. B is wrong. Then let's look at C. I think I need to erase this so that I will have enough space to explain further. So if you look at C, you have hydrogen, which is what? 1s1. Then you have helium, which is what? 1s2. So within the s orbital, helium has 1 electron, but sorry to say, hydrogen have 1 electron, but helium have 2 electrons. So C is not the answer. Now let's move over to D. I think D should be the answer, because if you look at lithium, lithium is 3. Lithium is equal to 3, which is equal to what? 1s2, then 2s1. So you have one electron only in an s orbital, which is helium. Then look at chromium. Chromium is 24, which is what? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, then 3d5. So you can see that helium has what? 1 electron only in an s orbital in the ground state, which is the 4s1. So the answer to this question is what? D. So as you can see, it's as simple as what? A, B, C. So the next question is, the ion X2 plus has the same electronic configuration as the atom krypton. What is the electronic configuration of an atom of what? X. So krypton, the atomic number for krypton is 36. So if it has the same electronic configuration, that means the number of electrons is what? 36. Then what is the electronic configuration of an atom of what? X. What that means that what? An atom of X will now be what? Since X2 plus is equal to, has the same electronic configuration as krypton, that means X2 plus is equal to what? 36. So if X2 plus is 36, X now will be equal to what? 38. So now we'll not check the electronic configuration. We'll now check the one that have electronic configuration of 38 and follow the Abba principle. Now if you look at A, argon is 18 plus 2, 20 plus 10, 30, 36. So A is not the answer. Then if you look at B, argon is 18 plus 2, 20 plus 10, 30, then 36, then 38. So I think the correct answer to this question is what? B. B is the answer, because it follows the Abba principle, and it also what? Have what? An electronic configuration of what? 38. The number of electrons there is what? 38. If you look at C, C is not the answer because it doesn't follow the Abba principle. It didn't follow the deviation principle. There's a deviation for the Abba principle. So C is not the answer. If you look at D, it doesn't follow the Abba principle also. So D is not the answer. So the correct answer to this question is what? B. That is the correct answer. So now looking at the question before us, when chlorine gas is analyzed in a mass spectrometer, ions are detected. Which row is correct? So if you look, we have what? Chlorine what? Chlorine 35. Positively charged chlorine 35. And the atomic number of chlorine is 17. Remember, atomic number is the number of proton, and the number of proton is equal to the number of electrons for a neutral atom. But this a charged atom. The atom is charged, so it's positively charged. So the number of proton is not equal to the number of electron here. So then I ask, which row is correct? Number of neutrons in chlorine 35. So to calculate the number of neutron is mass number minus atomic number, or nuclear number minus what? Number of proton, which is what? 35, which is the mass number, minus the atomic number, which is 17. So 35 minus 17 is what? 18. So the number of neutrons is what? 18. Now, the electronic configuration of chlorine 35, since the atomic number is 17, which is Cl, chlorine is 17, which is the number of protons, then Cl plus, that means here chlorine, a neutral atom, the number of protons equals the number of electrons, which is 17. But for a positively charged ion, the number of electrons is equal to the number of proton minus charge. So the number of electrons here will be equal to 17 minus 1, which is equal to what? 16. So if I have to write the electronic configuration, so it will be 1s2, 2s2, 2p6, 3s2, and 3p4. So the answer to this question is what? C. C is the answer. Number of neutrons is 18, and number of what? Number of electrons is what? 16. So you look at the electronic configuration, it follows the Abba principle. So the correct answer to this question is what? C. So this is the next question, and it's very simple. You are asked what is the electronic configuration of what? Magnesium what? Magnesium ion. The atomic number of magnesium is equal to what? Atomic number of magnesium is 12. So for magnesium ion, the number of electrons will be equal to what? The number of protons minus the charge. So the number of protons is 12. Because for a neutral atom, the number of protons is equal to the number of electrons. So the number of protons is 12 minus the charge. The charge is 2. So the number of electrons is equal to 10. So the electronic configuration of magnesium ion is what? 1s2, 2s2, then what? 2p what? 2p6. So the correct option, the correct answer to this question is what? A. It's as simple as what? A, B, C. Now the next question is, where in the periodic table is the element that has an outer electron shell arrangement of 4s2, 4s2, then 4p3? Now, where in the periodic table is the element that has an outer electron arrangement? When we say an outer electron arrangement, that is the number of electrons in the outermost shell. And the outermost shell is the fourth shell here. The outermost shell here is the fourth shell, and the electrons are the S subshell and the P subshell. So the total number of electrons in the outermost shell is 2 plus 3, which is equal to what? Which is equal to 5. So that means they have 5 electrons in the outermost shell. So since it has 5 electrons in the outermost shell, it belongs to what? Group 15, which is group 5. It belongs to group 15. Then the period is the number of shell, and the number of shell here is the fourth shell. So the period is 4, and the group is 15. So the correct answer to this question is D. D is the correct answer. So A is wrong because A is group 13 and period 3. So it is not correct. B is 13, period 4, so it is wrong. C is 15, period 3, it is wrong. So the correct answer is D is the correct answer. It belongs to group 15, period period 4. So having considered topical questions AS paper 1, which is the multiple choice, now I want to look at topical questions AS paper 2, which are the structured questions on electrons, energy levels, and atomic orbitals. So the first question is, the diagram below represents the energy levels of the orbitals present in atoms of the second period lithium to neon. You have to label the energy levels to indicate the principal quantum number and the type of orbital at each energy level. So for a second period element, the principal quantum number and the type of orbital at each energy level will be 1s, 2s, 2px, 2py, and 2pz. So as you can see, it's as simple as A, B, C. Now, if you look at the next question, on the axis below, draw a sketch diagram of one of each different type which is shape of orbital that is occupied by the electrons in the second what? In the second period element. So label each type. The first one is spherical. So you have the S subshell. For a second period element, you are going to have the S subshell and the P subshell. That is the S orbital and the P orbital. So the S is what? Spherical in shape. So you write spherical. Then the P subshell, which is dumbbell. So this is a dumbbell shape. So which is what? Px. So as you can see, it's as simple as what? A, B, C. So you have the spherical shape and the one that is what? Dumbbell. So the next question is complete the electronic configuration of nitrogen atoms and oxygen atoms on the energy level diagram below. Use arrows to represent what? To represent electrons. So if you look at it, this is nitrogen. If you remember Pauli exclusion principle, it says that what? The maximum number of electrons an orbital will take is 2, and those electrons must spin in opposite what? Direction. Nitrogen is equal to 7. So based on Pauli exclusion principle, an orbital can take a maximum number of 2 electrons, and they must spin in what? In opposite direction. So nitrogen is 1s2, then 2s2, then what? 2p3. So this one will spin up and down. They will spin like this in opposite direction. Then you have 2p3, 1, 2, and what? And 3. Then the next one is oxygen. Oxygen is what? 8, which is 1s2, 2s2, then 2p what? 4. So applying what? The Pauli exclusion principle and the Hund's rule. So you have this one will be 2s2, they will spin in opposite direction. Then you have 2p4. Then so this height to spin. So you have to what? Apply what? The Pauli exclusion principle and the what? And the Hund's rule. So this is the correct what? Correct answer to this question. The next question is complete the table which describes a gaseous atom of gallium. So if you look at the table before us, you have to complete the nuclear number, the total number of electrons in lowest energy level, the type of orbital which contains the electrons in the highest energy level. So the first thing you have to do is to write down the atomic number of gallium. So gallium is what? Gallium is 31. The atomic number of gallium is 31. So the next thing, you have to write the electronic configuration of gallium. Gallium is 31. So you have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3g10, then 4p1. So the next thing for you to do is to complete the table. So the nuclear number is the mass number. So the nuclear number of gallium is 71. Then the next one is the total number of electrons in the lowest energy level. So if you are to follow the Abba principle, so the total number of the lowest energy level is what? 1s, which is 1s2. So the number of electrons there is what? 2 electrons. 2 electrons on the S subshell. So that is the total number of electrons in the lowest energy level. Total number of electrons in the lowest energy level is 2 electrons. Then you now ask the type of orbital which contains the electrons in the highest energy level. So the electron in the highest energy level is 1. Then the type of orbital in the highest energy level is the p orbital, because this is the highest energy level going by Abba principle. So the type of orbital which contains the electrons in the highest energy level is what? Is the p orbital. So it is the p orbital. So it's as simple as what? A, B, C. What you need to do, you need to check for the atomic number of gallium, and then you write the electronic configuration and follow what? The Abba principle. So the question before us, this question is about the bonding of covalent compounds. Then on the axis below, sketch the shapes of a 1s, a 2s, and a 2px orbital. So what you have to do is For the 1s, it is spherical in shape. For the 2s, spherical also. Then for the 2p is dumbbell shape. So here you have your 2p or 2px. So it's as simple as what? A, B, C. All you just need to know is just the shape of what? The orbitals. So if you look at this question, copper and titanium are each used with aluminum to make alloys which are light, strong, and resistant to corrosion. Aluminum is in the third period of the periodic table. Copper and titanium are both transition elements. Complete the electronic configuration of aluminum and that of titanium with proton number 22. So it's as simple as ABC. Aluminum is 13, so 1s2. So you have what? 2s2, 2p6, 3s2, then 3p1. So aluminum is what? 13. So titanium is what? 21, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d2. So that's the electronic configuration of what? Titanium and what? And aluminum. All you just need to do, you follow the upper what principle. Here you start filling from the lowest energy level to the what? Highest energy level. So the next question is, electrons in atoms up to krypton are distributed in s, p, and d orbitals. You are asked, state the number of occupied orbitals in an isolated atom of krypton. So the type of orbital are s, p, and d. Then the number of orbitals. So we already know the atomic number of krypton, which is what? Krypton is 36. Is equal to 36. So we have to write the electronic configuration. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, then 4p6. So we have to state the number of occupied orbitals in an isolated atom of what? Krypton 36. So let's start with the s orbital. Type of orbital s. So the number of orbitals, the first we need to look at the number of electrons on the s orbital. So we'll have 2. This is 2 plus here on the s 2 plus another 2, then plus another 2. So the total number of electrons on the s orbital is equal to what? 8. And based on Pauli exclusion principle, the maximum number of electrons that an orbital can take is 2, and they must spin in opposite direction. So if an orbital can take 2 electrons, that means 8 electrons would take what? 4 orbitals. So the answer to this question is what? 4. On the number of orbitals, the number of orbitals will be equal to what? 4 for the s subshell. So the number of orbitals will be 4. Now let's go to the p. Now if we go to the p subshell, let's see the number of electrons there. We'll have 6 on the p subshell, which is 6 plus another 6, then plus 6 also. So the total number of electrons is equal to what? 18. So if 2 electrons can occupy an orbital, 18 electrons, if 2 electrons can occupy one orbital, 18 electrons occupy what? 9 orbitals. So the answer to this is what? 9. So the p subshell will take 9. Now let's go to the d subshell. The d subshell have only what? 10 electrons. So if 2 electrons will take 1 orbital, 10 electrons is going to take what? 5 orbitals. So the answer to the question is what? S will take 4, P will take 9, and D will take what? 5. So it's as simple as what? A, B, C. So the next question is, complete the diagram to show the number and relative energies of the electrons in an isolated atom of silicon. So silicon is 14. The atomic number of silicon is 14. So you write the electronic configuration, which is 1s2, 2s2, then 2p6, then you have 3s2, then you have 3p2. So you have to fill, the orbital. An orbital can take a maximum of 2 electrons, and they must spin in opposite direction based on Pauli exclusion principle. And in Hond's rule, you fill singly before you start what pairing. So electrons are filled singly before what pairing begins. So this one s2. So this one will be what? 2s2, then 2p6, then 3s2, then 3p2. So this is what, how you can fill how you can fill the orbital box diagram for silicon. So you have to obey the Pauli exclusion principle, and you have to obey the Hond's rule. Then the next question is, the diagram shows a type of orbital. From the shape, it is dumbbell shape. So the type of orbital is p orbital, is the p subshell. Then the next question is, state the total number of electrons that exist in all orbitals of this type in an atom of fluorine. Fluorine is 9, so you write the electronic configuration of fluorine, which is 1s2, 2s2, then 2p 2p5. So the p orbital contains 5 electrons. So the total number of electrons that exist in a p subshell or the p orbital is 5 electrons. So as you can see, it's as simple as A, B, C. So please attempt as many questions as possible. Go through the video, and subscribe to my YouTube channel, like, comment, and share. I'm Mr. Joseph, your chemistry teacher. Please feel free to reach out to me if you encounter any difficulty. I'm always there for you to help. I'm Mr. Joseph, your chemistry teacher. Please don't forget to subscribe. Don't forget to share. Don't forget to like. Thank you for listening. I'm Mr. Joseph, your chemistry teacher. I'm Mr. Joe, your chemistry teacher. Thank you for listening. Thank you very much.